All right, we're going to talk for a couple minutes now about landscape characteristics. All right. Landscapes are the visible part of Earth's surfaces, what you see when you look outside. It's your hills and your valleys and all that kind of stuff. All right. So we're talking about, again, hills, slopes, stream patterns, soils. We look at a couple different things when we want to differentiate landscapes. All right. Gradient. How steep is the land? Generally speaking, we associate steep land with mountains, that kind of thing. And elevation, specifically the relief of elevation. Relief is the difference in the highest and the lowest points. And then finally, we look at bedrock structure. Right? Probably one of the most important things to differentiate your landscapes is your bedrock structure. If you dig down into the ground, what does it look like? Is it horizontal sedimentary layers? Is it distorted metamorphic rock? Is it giant igneous rock bodies? What is it? So that's what we look at. All right. This is out of page 2 in the reference tables. This is our landscape region page. Here in New York, we have a very high number of different landscape regions. Right? There's some states, particularly Midwest, Plain states, Kansas, things like that, that basically are one landscape region, the entire state. Okay? Very boring. New York has 13 different landscape regions. Okay? And we separate all those landscape regions out by looking at drainage patterns. What do the river systems look like? What are the different elevations that we have, the changes in elevations, and again, the bedrock structure. What does the rock look like in our state? All right. So if you take a look at this map real quick. So if you look down here, we've got a little key, talks about things. The solid line separates the major geographic regions. So for example, we've got a line here that separates the Allegheny Plateau from the Erie, Ontario lowlands. All right. Separate individual little landscape regions are separated by these little dashed dotted lines here. We have our state boundaries here. Okay, New York here, Pennsylvania here. And then we have our international boundary right here. So we have the USA and Canada. All right. So if you notice, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which is right there, 11, 12, and 13, right there. Okay, so we've got 13 different regions in New York State. Say what you want about other things, political, financial, very expensive, high taxes, that kind of thing. But just aesthetically, we have a very beautiful state. We have all kinds of different natural wonders in our state. All right? But if you look also, this and this are both inside this line. Try that again here. Here, and even here, you can see fall inside this one dark line right there. So even though we classify them as separate landscape regions, they're actually technically part of the larger region. All right? Tug Hill Plateau, Allegheny Plateau, Catskills, those are really all part of what's called the Appalachian Plateau. right? And it extends southward out of New York, right? These boundaries that we talk about, these state boundaries, those are political boundaries, right? Just because we have a political boundary in two different states doesn't mean that the bedrock on each side of that boundary is different. You don't cross over into Pennsylvania and go, oh, we got a different bedrock underneath our feet now. No, those are political boundaries, okay? A couple other examples. St. Lawrence lowlands, Erie, Ontario lowlands, Champlain lowlands, right? Mohawk Valley lowlands. These are really part of a larger region called the interior lowlands, which includes areas that move up into Canada. Again, we're talking about a boundary, a political boundary now, so bedrock doesn't change just because you cross over into a different country. Let's see. Those two regions right there, the Adirondack Mountains and the Taconic Mountains, are the only true mountain ranges in New York. All right? They were formed by mountain building processes, collisions of continents causing uplifting, folding of the layers, and mountains. Okay? The Catskills are sometimes referred to as the Catskill Mountains, but they're not actually a mountain, they're a plateau. Again, we talked a little bit about plateaus, but we'll talk about the difference between them as we move forward here. All right. All right, here's a little map of the whole United States, kind of showing some of the major physiographic provinces. You can see the Adirondacks up here. You can see this Appalachian Plateau extends all the way down into Alabama. All right. This Atlantic Coastal Plain, which is Long Island, is part of a larger coastal plain all the way down into Florida, up into Tennessee and Missouri, down into Texas. Is all one giant landscape region. That map I just showed you is just the portion that's in New York. All right, major landscape groups. Three major groups of landscapes we break things up into. Plains, P-L-A-I-N-S, not P-L-A-N-E-S. Okay? Plains as in flat areas, low-lying areas. Mountains and plateaus. All right, I'm not going to spend a lot of time on plains. I think most people know, a very low, flat, wide open area is a plain. Right? Mountains and plateaus can be a little bit more difficult to distinguish. All right, there's a few key differences. If you look at the pictures, they kind of help describe that. All right, the major difference between a mountain and a plateau is bedrock structure. In a mountain, the way we get a mountain is through uplifting processes, collisions of continents causing the ground to warp upward and bend and twist and all that kind of stuff. So we end up with these twisted rock layers, folded, twisted rock layers, and it's mostly igneous and metamorphic rock. Okay? Igneous because the continents were essentially mostly igneous, and some of that igneous is transformed regionally into metamorphic rock during that process of continental collision. So we get a lot of igneous and metamorphic rock, but the rocks are all distorted and twisted and wavy and all that kind of stuff. All right? Whereas in a plateau, even though on the outside it may look like a mountain, you're standing in front of it and it's tall, it's got steep sides, it looks like a mountain. But if you were to dig down into the ground, you can see this in the canyon walls. You can see these nice horizontal layers. Okay, nice horizontal layers as opposed to these distorted layers over here. Okay? But also, these horizontal layers are predominantly sedimentary. Okay? We're not getting a lot of igneous and metamorphic. This wasn't caused, these weren't caused by uplift. These were caused by a plateau, a high area that was carved down into by water. a river running down through the center of it, carved down into the rock over millions of years. And you can see these sedimentary layers in the wall afterwards. That's the big difference. Even though they both look similar, can look similar, they both have high elevation, steep walls, that kind of thing. It's the structure of the bedrock underneath that differentiates a mountain from a plateau. Remember, a mountain is caused by collisions of continents, causing uplifting and twisting and warping and regional metamorphism, where a plateau is just simply an area that had high elevation already, and the running water in different places just cut down through it, creating steep walls, and you can see the sedimentary layers. All right, landscape development. How do we develop those landscapes? Well, there's some competing forces at work here. All right. First is what's called, we'll call uplifting forces. All those things that build up mountains or make continents bigger or raise or roughen up the Earth's surface. All right. So earthquakes, volcanic activity, plates colliding with each other, diastrophism, which is just a big fancy word for deformation of the Earth's crust when it twists and warps and gets all distorted and things like that. You don't need to really remember that word. But all those things that are going on inside the Earth from the motion builds up the landscape. Right? Now, competing against the uplifting forces, okay, would be the leveling forces. Okay, so if uplifting forces are dominant, the Earth rises up. Leveling forces, gravity, running water, glaciers, wind, those things that lower the elevations or wear the Earth down. All right. If the leveling forces are dominant, then the Earth becomes flatter. And it just depends on which force is at play at any particular moment as to what the landscape's doing. If those forces are in balance, overall, we're in what we call dynamic equilibrium, and the landscape doesn't really change much in terms of elevation-wise, right? But again, if we have more tectonic activity, the land is going to rise up. If we have more weathering, more eroding forces, the land is going to go down. And it just depends on which force is dominant at a particular moment as to what it's doing. For example, in the Himalayas, India colliding into Asia, right now, uplifting forces are dominant, and so Mount Everest and K2 and all those they are currently getting taller because uplifting forces are dominant. They're rising by, a couple centimeters a year. Whereas in the Adirondacks, those uplifting forces are no longer present, and so all that's working on the Adirondacks is erosion and leveling forces and bringing the surface down lower. Right? All right, how does climate influence landscape? All right, a couple different ways. If you've got a humid climate, if you live in a humid climate, that moisture that's in the air constantly is going to help to smooth out your landscapes and make them a little more rounded. Whereas if you live in a dry climate, like the Southwest, Phoenix and Nevada and Southern California and all that, that lack of moisture tends to make the rocks jagged. They break off much easier instead of kind of wearing down easily. Right? Areas where you have moisture, you're going to get pretty good soil fertility. They're good for growing. Whereas, again, in that Southwest area, you can't grow a whole lot. They don't have many lawns and trees down there, right? Because the soil is not really fertile because there's no moisture to help things grow. Generally speaking, we get a significant amount of rainfall over the course of the year, and it's pretty widespread, pretty evenly dispersed throughout the year in terms of moisture coming from precipitation, snow and rain. But in arid regions, they don't get very much rainfall. But when they do, it usually comes in small, little localized storms, little rain bursts. And those little storms can actually lead to localized temporary flooding in an area until eventually it stops. And then because it's so hot, we get a lot of evaporation and it goes away. If there's a lot of people that like to hike in the canyons, in some of these areas, Utah and Nevada and Arizona, there's a lot of hiking going on in some of these dry desert canyons. And if you happen to be in one of those canyons hiking and a storm pops up, there's a very real risk of localized flash flooding through those canyons. And not to be morbid, but they have found bodies in these canyons after these flash floods from these storms that popped up. And when they autopsied the body, they found out that the person died from drowning. They were in a desert canyon and they drowned because they got caught in this flash flood and they couldn't get out. So, our vegetation, the trees, plants. Humid climates tend to give us a lot of both deciduous and coniferous. Remember, deciduous are your trees that lose their leaves in the fall. Your coniferous or cone-bearing are the ones that are your evergreens. Okay? They don't necessarily drop there are a few coniferous plants that do drop some of their needles. But for the most part, they hold on to their needles year-round. They stay green year-round, your Christmas trees, things like that. And arid regions tend to have very limited vegetation. If anything can grow at all because of the lack of moisture, it's usually going to be very small shrub-like plants, things that don't need a lot of moisture. You're not going to get large foresty areas that develop in dry regions. All right, drainage patterns. I talked earlier a little bit about all the different drainage patterns that are in New York State. Drainage pattern is essentially if it rains in an area, what do the streams that develop look like? And a good example is if you look at a mountain, a volcano, it's got a peak. And if it were a cloud to form over this and rain on this peak, you're going to get water running down all sides of this mountain, and it's going to look something like this. That's called a radial pattern. Right? And there's a bunch of different patterns depending on what the ground looks like. Right? So all you really got to do is just match the shape of the indentations in the ground to the water, and that's going to give you kind of what the shape of the drainage or the rivers are going to look like in any particular area.